Hi, I'm Scott Kotvis and welcome. This presentation titled VCI 101 Principles and Products is brought to you by Daubert Cromwell, the leading name in corrosion prevention. In this presentation, we will 1. Introduce volatile corrosion inhibitors, 2. Discuss the principles of how they protect metals from corrosion, and finally, number 3, look at VCIs used in packaging products. So let's get started. It is an inescapable consequence of nature. Metals corrode. But why? The cycle begins when energy is added to produce a product. Then, during the metal product's entire life, that metal wants to return to its low energy state. That reduction of energy is corrosion. Corrosion is actually an electrochemical reaction. When water and oxygen are combined on the metal surface, an ionic current takes place. Over time, we see orange or red rust. This demonstrates what is called reduction at the cathode. You might recall on your own, rust can cause pitting. Pitting demonstrates the reduction or the oxidation taking place. The metal is returning to its original low energy state. For centuries, people have protected metals from corrosion using rust preventive liquids. Applied by spray, brush, wipe, or dip, today they are available as solvent-based, oil-based, and water-based carriers. The intent of using them is to break the electrochemical corrosion current. While RPs, as they're called, are used, sometimes they just don't do the trick. They don't protect the metal or are undesirable for other reasons. We see this especially for export shipments of metals and long-term storage. Over time, RPs may fracture and expose the metal to corrosion. In other cases, RPs may trap moist air, also leading to corrosion. So here we are, VCIs, or volatile corrosion inhibitors. In the form of packaging materials, we make dry, clean, and safe corrosion prevention. We do this by coating paper or extruding into polyethylene plastics our VCI chemistries. When users wrap their metal parts, the VCI goes into action. Because VCI molecules are attracted to the metal, they transfer or volatilize to the metal surface. We see this process as 2 steps in these slides. This attraction continues until the entire available surface area is covered with a layer of molecules that essentially acts as a barrier that prevents harmful substances and electrolytes from contacting the metal. The charged molecules passivate the metal, reducing electrochemical stress on its surface and preventing the corrosion cell from setting up. Naturally, the term VCI is typically associated with being volatile, meaning it can protect metal even if it is not in direct contact with it. However, VCIs from Daubert are also contact-oriented. They are compatible with the metal as well as any residue that may be on the metal surface. Importantly, they do not react negatively with the metal by holding potentially aggressive elements such as moisture or even acid from the paper that's in direct contact with the metal. Poorly designed VCIs can actually cause corrosion if, for example, they are too concentrated or not pH balanced. Parts wrapped in Daubert Cromwell packaging remain corrosion-free for as long as the package stays intact and the part is insulated from corrosive elements. This gets us to the point of corrosive elements. VCIs require that best practices are implemented. For example, if the metal surface is not clean, it may block the VCI from getting to the surface. If that metal is contaminated, it can also lead to corrosion. Examples of contamination include non-neutral pH oils like fingerprints or upstream processing fluids. They also include high sulfuric acids and even dirt or dust. On the other hand, because water droplets can occur inside a package, it is important to know that our VCIs are also water soluble. This is especially important for export packaging. During the months of transit, a container will experience several temperature change cycles. Each time the temperature cools, warm, saturated air condenses and forms water droplets. This emphasizes the need to use a packaging material loaded up with plenty of VCI. Each time the water droplet drains, it will carry away a protective layer, or at least a portion of it. Having the reserves of VCI remaining in the packaging material assures the metal will draw more VCI, self-healing, to maintain proper amounts of VCI on its surface. There are many critical factors to selecting VCIs. Some are listed here. While we don't have time to go over all of them in this short presentation, just remember, not all VCIs are the same. For this presentation, we focus on packaging materials that incorporate VCI. Poly or polyethylene is a very popular packaging that we incorporate our VCI. We do this in the extrusion process. VCI poly is versatile and available as sheets, flat bags, gusset bags, stretch, barrier laminates, reinforced weaves, high strength, bubble, ESD, shrink, pre-open, bags on a roll, the list goes on. Here are some examples of those products in use. Paper-coated VCI is the oldest and most traditional method of delivering VCI. It continues to be popular due to the large amounts of VCI that can be loaded onto a square sheet. VCI devices also add an important dimension to corrosion prevention packaging. Devices that give off or emit VCI compounds protect recessed areas within a package that may not be close enough to the VCI packaging itself. These devices can be inserted in hard-to-reach areas. Often, they are used simply to enhance protection by giving a boost of available VCI. In some cases, a VCI pouch or chip can be added to a plain poly bag to promote VCI protection where none existed before. A variety of liquids are also available to add protection. Some of our VCI liquids are oil-based, water-based, and glycol-based. While outside the discussion of packaging, it shines a light that while we are the leader in VCI packaging, we also are involved in non-packaging corrosion protection. I hope this gives you a glimpse of VCI, or volatile corrosion inhibitors, its principles and how they protect metals from corrosion, and how VCIs are used in packaging materials. Thank you very much. Hope to see you again.